Hi there, folks. Today we're looking at parallel and perpendicular lines, what those things are, what they mean in terms of algebra, and then we're also going to start writing equations based on whether we have a parallel or perpendicular line. So, parallel and perpendicular lines, first of all, parallel lines are coplanar lines that never intersect. And that whole coplanar thing, you don't have to worry about that. But I throw that at you because that's a term you're going to see in geometry. All right, so it's just kind of a little preview for something that you're going to see later. But just remember, they're lines that never intersect. Parallel lines are lines that kind of run side by side. All right, and so that visual concept of parallel lines is important. If they run side by side, they're never going to touch, like something like train tracks. All right, though those two metal posts that the wooden pieces run across, those are parallel lines essentially. All right, and if they intersected, that would be a real problem for the train. All right, the symbol for parallel lines, we just use a little set of parallel lines. So if you see two little slashes like that, a little pair of parallel lines, that indicates parallel lines. All right, that's the symbol we use. For algebra purposes, when we're talking about lines, the thing about parallel lines is that their slopes are the same, all right? So if two lines have the same slope, it means that when we graph them, we'll have parallel lines, okay? If we have two parallel lines, well, then if we know the slope of one, we automatically know the slope of the other. Their slopes are the same. Because again, slope kind of describes the steepness of this thing. And so if they have the same steepness, they kind of shoot off in the same direction, which means they're parallel. Okay? Perpendicular lines are lines that intersect at a 90-degree angle. Visually, we just think of this as, hey, lines that intersect perfectly, all right? When they intersect, all the angles look the same, all right? So when those two lines cross, all the angles look the same. They're all 90-degree angles. They're all right angles, all right? The symbol for perpendicular lines looks like a little pair of perpendicular lines. It's like an upside-down T. And the reason we don't, if you think about perpendicular lines, here are some perpendicular lines. The reason we don't use that as a symbol is because we kind of already have a symbol that looks like that. That's a plus sign. All right, so we use that upside down T. And yeah, the reason we don't do it as a capital as the other way is because then it looks like a capital T. All right, so we're just showing a little set of parallel lines and we're trying to come up with a unique symbol. That's the only reason we use that particular set of perpendicular lines, okay? Perpendicular lines, the thing about them from an algebraic perspective, when we're talking about the equations, lines, stuff like that, their slopes are opposite reciprocals, okay? And so the word opposite means a different sign, okay? So different sign, and reciprocal means we flip the fraction, all right? And so if you want to put a little note to yourself there, students really mix these up a lot because it's two things. So for the slopes, it's a different sign, so different sign, and flip the fraction. And you have to do both of those things. Okay, so if one of them is a 2 over 3, the other one has to be a negative 3 over 2. If one of them is a negative 5, which is like negative 5 over 1, the other one has to be positive 1 over 5, okay? So we have to change the sign and flip it, different sign and flip the fraction, all right? And so parallel lines, the slopes are the same. Perpendicular lines, the slopes are opposite reciprocals, okay? For example, if we look at some of these guys, I've got a couple different sets here. It says find the slope of the line, then state the slope of the line that's parallel, and then state the slope of the line that's perpendicular, okay? So for this one, I'm going to start off the same way I always do. I'm going to find the slope using my slope formula. So for this one, remember the slope formula is the second y value minus the first y value over the second x value minus the first x value. So the second y value is a 7 minus the first y value is a negative 3. Second x value is a 4 minus the first x value is a 2. And remember, subtraction, same as adding the opposite. So that's going to give me a 10 over 4 minus 2, which is a 2. When I divide those, I get a 5. So the slope of this thing, so I'm going to write it again, the slope is 5. But now let's talk about the slope of the line that's parallel to this thing. Remember, parallel lines have the same slope, so if the original slope is 5, the parallel line also has a slope of 5. The slopes are the same, okay? And now let's talk about the slope of the perpendicular line. Notice I just used the little perpendicular symbol so that I know, all right? So now think about this for a second. This guy was like 5 over 1, right? So if I want the perpendicular line, I have to do the opposite. So that was a positive 5 over 1. So I'm going to do the opposite, which is a negative. And I want to do the reciprocal, which means flip it. So instead of 5 over 1, it's 1 over 5. And that's how slope compares when you're talking about parallel and perpendicular lines, okay? If the line has a slope of 5, a parallel line would also have a slope of 5. If this line has a slope of 5, then the perpendicular line would have a slope of negative 1/5, okay? If I look at the next one, same kind of thing. So I've already got my slope formula written down. It was the second y value minus the first y value over the second x value minus the first x value. I'm going to go right to writing down the numbers since I can still see the equation over here. So let's see, the second y value is a 4 minus the first one is a 1. Second x value is a negative 2 minus the first x value is a 0. And now 4 minus 1 is a 3. Negative 2 minus 0 is a negative 2. And really, when I typically write things like this, I don't typically write the negative in the denominator. I stick it with the numerator, or I write it out front. So negative 3 over 2. Okay? So that's the slope of the line. The parallel line, the slope is going to be the same. So if that was a negative 3 over 2, this is also a negative 3 over 2. But then the perpendicular line is opposite reciprocal. So I change the sign and I flip the fraction. So the opposite of a negative is a positive. And then when I flip the fraction, instead of 3 over 2, it's 2 over 3. And notice it's a positive 2 over 3 because I do the opposite reciprocal. Okay? Parallel lines, the slope is the same. Perpendicular lines, it's the opposite reciprocal. Okay? If I look at the next one, again, I already have the formula. I've done it a couple times now. Second y value minus the first y value. Second x value minus the first x value. Again, subtraction is the same as adding the opposite. So that gives me a negative 10. And that's a negative 10 over 0. We know that we can't divide things. Sorry, that's a terrible looking m. My m's are getting worse and worse as I go. Shameful. We know we can't divide by 0 here. Negative 10 divided by 0 is impossible. For slope, we call it undefined. But now the same rule applies if we're talking about the parallel line, the slopes are the same. So if the original slope was undefined, well then guess what? My parallel line, the slope is also undefined. The place this becomes a little bit tricky is when we're talking about the perpendicular line. For the perpendicular line, it's supposed to be the opposite reciprocal. Well, undefined is kind of hard to do the opposite and flip it, right? So go back to when you had numbers. Look at this guy right here. Here's some numbers, right? It was a negative 10 over 0. So instead of negative, I'm going to make it positive. And instead of 10 over 0, it's going to be 0 over 10. But 0 divided by 10 is just a 0. Okay? So that's the perpendicular line. And really, when you think about it, undefined means that this thing is a vertical line, right? The slope of a vertical line is undefined, which means the perpendicular line must be a horizontal line. Well, horizontal lines have a slope of 0. Okay? So there's two ways to think of it. And really, if you kind of just step back from the math for a second and just think about an undefined line as being vertical, well, the perpendicular line has to be horizontal. That's a slope of 0. Okay? Or just go back to when you had some numbers and change the sign and flip it. Okay, so that's the relationship between the slopes, and algebraically, that's the thing we're kind of looking for. So if we're looking at some of these guys, it says determine if the lines are parallel, perpendicular, or neither. And the thing about this, when we're looking at an equation, think about the 3 equation types we've had for lines. There was point-slope form, slope-intercept form, and standard form. Okay, and when you think about those 3 formats, 2 of those formats gave us the slope, and 1 of them did not, okay? Point slope form and slope intercept form have the slope written as part of the format, okay? But standard form doesn't. So when you look at these, like this first set of examples, if you look, this guy is written in standard form, which means none of these numbers represent the slope, okay? This guy is written in slope intercept form, which means this guy is the slope. And so if I want to compare the slopes, I need to have each of these written in a format that makes sense. So like that first equation is kind of useless to me right now. All right, this is standard form. From standard form, remember, it's easy to convert to slope-intercept form. We just have to move the x. So I'm going to add that 3x to each side. Now this equation says y equals 3x plus 5. See, now I can compare these two. Let me rewrite that second equation. It was y equals 3x minus 6. Now they're both in slope-intercept form. They're both in a format that gives me the slope. This one, I can see that the slope is a 3. This one, I can see the slope is a 3. So the slopes are the same. So these are parallel lines. So I would say, hey, these are parallel lines, so I'm just going to write parallel. Or really, if you want to use the symbol for parallel lines here, if you just want to say, yep, parallel, that would be fine as well. Okay, just use the little symbol. But I know that by looking at the slopes. If I look at the next example is a really easy one, because if you look at that first equation, that's in slope-intercept form. And then if you look at the second equation, that's in point-slope form. They're both already in a format that gives me the slope. And so when I look at this first one, the slope of that first equation is a -2. It's written right there. The slope of the second equation is right here. It's that +1/2. See, they're already written in a format that gives me slope. So it's important to be able to recognize the format that these things are in. Okay? And we've just been doing quite a bit of that, so hopefully that's not too bad. All right? But now I look at these things and I say, okay, those slopes aren't the same, so these are not parallel lines. But then I got to ask myself, are they opposite reciprocals? Well, one's a positive and one's a negative, so they're opposites. One is a 2, which is like 2/1, and the other one is a 1/2, so they're reciprocals, okay? If you change the sign and flip one of those, I get the other thing. So these are perpendicular lines, so I'm going to say perpendicular. Or if you just want to write the symbol, that would be fine as well, okay? And then if I look at the last one here, well, the last one in this set of examples, again, that first one is written in slope-intercept form, so that one gives me the slope. That one's great. But the second one is written in standard form, which is no good. So I want to rewrite this. Let's add the 3x to each side. And when I do that, it gives me y equals 3x plus 2. So now if I rewrite that first equation was y equals 1/3 x plus 5. So now these are each written in slope-intercept form. The slope of this first one is a 1/3. It's written right there for me. The slope of this second equation is a 3. It's written right there for me. And so when I look at these, they're not the same, so they're not parallel, okay? But then the question is, are they opposite reciprocals? And when you look at a 3 versus a 1/3, those are reciprocals. If I flip one of those, I get the other. But they're not opposites. They're both positive. So these are not parallel or perpendicular. This is the scenario where I would say neither. Okay? And this is the one that students always get mixed up on. They see those reciprocals and they say perpendicular. But remember, it has to be opposite reciprocals. Okay? If you look at the previous example, those are reciprocals, but one's positive, one's negative. Okay? So then writing equations just like we've been writing them, it says write the equation of the line in standard form that is parallel to y equals a -2x plus 4 and passes through the point -6, 4. Okay? And so when you look at something like this, remember, all we're going to do when we write an equation, even in standard form, I always start with point-slope form. Okay? Remember, point-slope form is y minus the y value equals m times x minus the x value. And so the question is, what's the slope of my line going to be? Well, it says that I want to be parallel to this guy. Well, this guy has a slope of -2. And we know that parallel lines have the same slope, so my line is going to have a slope of -2 also. Okay? And now I just plug in the point that they gave me. Remember, in point-slope form, it's the opposite of each of those values. So here it was y, and then the opposite of the y value. The y value was a +4, so I wrote a -4. Over here, it's minus that x value, so it's the opposite of that x value. So instead of a -6, I read a +6. Okay? Remember, those minus signs in the equation are like opposite signs. Okay? So now there's the equation of the line. It's just not in the format that they asked for. This is in point slope form. If the question had asked for point slope form, I'm done. But it didn't. It asked for standard form. So remember, I rewrite it in slope intercept. I distribute. It's always the same couple steps. And then I add the 4. And once again, this is slope intercept form. So if the question had asked for slope intercept form, then that would be my answer. But it didn't. It asked for standard form. So I have one more step. Remember, with standard form, we got to get the x and the y on the same side. So I'm going to add that 2x over to the other side. And remember, make sure you just put it in the right order. I write the x value, then the y value equals the number. Okay? But we're going through the same thing that we've been going through. This is just one more way that they can tell us what the slope is. Okay? So this is no different than the equations we've been writing, except this one, the slope was actually really easy to find. Okay? If I look at the next one says write the equation of the line in point slope form that is perpendicular to y equals a -2x plus 5 and passes through the point 3, -1. So once again, point slope form, y minus the y value equals m times x minus the x value. But this time it says I want to be perpendicular. So right here, the slope of this line is a -2. But I don't want to have the same slope as that line. I want to be perpendicular to that line. So perpendicular would mean that the slope has to be the opposite reciprocal. So opposite is a positive. And when I flip it, it's a +1/2. So now I come back over here and say, okay, I've got my slope. I've got my m. Now I just have to plug in the ordered pair. Remember, those minus sign means the opposite. So the opposite of the y value is a +1. The opposite of the x value is a -3. That's the equation of my line, and I'm done. Okay? So I'm doing the same thing that I've been doing. They're just giving me new hints in terms of how to find the slope. Okay? And then if I look at something like these guys, these are kind of our special cases here. It says write the equation of a line that's parallel to y equals 4 and passes through the point -3, 5. And so here's the thing. Probably the easiest way to do this is to kind of think about a graph of this thing. So like y equals 4 is a horizontal line, remember? So there's the equation y equals 4. I want to be parallel to that, but go through the point -3, 5. Ready? -3, 5 is up here. And I want to be parallel to that line. Let me draw the parallel line. It's another horizontal line. So I just have to think about what the equation of that line is. Remember, horizontal lines are y equals. And look at where that line is. It's up there at y equals 5. I kind of missed the mark a little bit. But I just say, hey, it's y equals 5. And so when you're thinking about parallel and perpendicular lines and you start getting into vertical and horizontal lines, it's always easier just to think about the graph, okay? And think about what the line looks like. It's using that visual representation of parallel and perpendicular is much easier, okay? Same thing with the next guy. It says write the equation line that's perpendicular to the x-axis and passes through the point -2, 6. And so once again, if we kind of think about a graph here, all right, so here's -2, 6. -2, 6 is right here. And I want to be perpendicular to the x-axis. Well, here's the x-axis, right? The x-axis is right here. So if I want to be perpendicular to the x-axis, I want to draw this line straight up and down. Well, that's a vertical line. So think about how to write the equation. Vertical lines are always x equals a value. And so look at that vertical line. Look at where it is in terms of x. It's the vertical line at -2, so it's x equals -2. There's not really much math involved there. It's just understanding the visual relationship between parallel and perpendicular and the idea that y equals as a horizontal line, x equals as a vertical line, okay? But again, kind of wrapping this up, algebraically, when we're looking at these things, parallel lines, the slope is the same. Perpendicular lines, so here are parallel lines, the slope is the same. Perpendicular lines, the slope is the opposite reciprocal. Change the sign and flip it. But then when we're writing equations, we do the same thing we've always done. We start in point-slope form. We can convert that to slope-intercept form, and from there we can move it into standard form. Okay?